Imagine a moment in our history when humanity decided to send a message out into the vast unknown of space, not knowing if anyone or anything would ever receive it. Picture a small box-shaped spacecraft, no larger than a golf cart, speeding through the dark emptiness of space. Attached to it was a golden plaque, inscribed with symbols representing who we are as a species. This isn't science fiction. It's the real story of Pioneer 10 and 11, two spacecraft that became the first human-made objects to venture beyond the inner parts of our solar system, charting a course into the unknown. Over 50 years ago, in the early 1970s, these humble machines set off on a mission that would stretch the limits of technology and imagination. They weren't built to impress. They were modest, practical tools of discovery. And yet, they completely redefined what humanity was capable of. They were the spark that ignited our dreams of reaching the stars. What exactly did they find, billions of miles from Earth? And why do their journeys still resonate with us today? Let's rewind to the year 1972. The world was undergoing dramatic change. Disco was on the rise. Handheld calculators were cutting edge. Tech and NASA was preparing to take a bold leap into uncharted territory. Their goal was ambitious: send a spacecraft farther than anyone ever had. Beyond Mars, through the asteroid belt, all the way to Jupiter. The challenge was immense. Jupiter sat 10 times farther from Earth than Mars, and was wrapped in lethal radiation fields and powerful mysterious storms. And yet, NASA didn't stop at just one destination. They planned a second mission to go even farther, past Saturn, and into the deeper reaches of space. These missions, known as the Pioneer program, marked our first real steps into the outer solar system. Pioneer 10 launched on March 2nd, 1972, aboard an Atlas Centaur rocket. Its sister spacecraft, Pioneer 11, followed about a year later. Each one weighed around 570 pounds, roughly the weight of a motorcycle, and ran on a small nuclear battery no bigger than a toaster. These were not high-tech marvels by today's standards. Their onboard computers had less memory than a digital wristwatch, and their communication systems used about as much power as a refrigerator light bulb. But these spacecraft were designed with one purpose: to survive the unforgiving conditions of deep space and return data from regions we had only imagined. Their journey was anything but simple. To reach Jupiter, the probes had to navigate the asteroid belt, a dense field of fast-moving rocks and debris that scientists once feared would destroy any spacecraft trying to pass through. These chunks of rock, some the size of mountains, raced through space at speeds of up to 45,000 miles per hour. A single collision could have ended the mission, but against the odds, both Pioneer 10 and 11 safely crossed the belt, showing that the feared obstacle was navigable after all. By December 1973, Pioneer 10 had become the first spacecraft to reach Jupiter. It sent back images that, though grainy by today's standards, stunned scientists. Swirling cloud bands, chaotic storm systems, and the enormous Great Red Spot. A storm so vast it could engulf Earth several times over. But it wasn't just the visuals that shocked researchers. Jupiter's magnetic field turned out to be 20,000 times stronger than Earth's, emitting dangerous radiation that could destroy a spacecraft's systems in seconds. Pioneer's instruments recorded an invisible storm of high-energy particles, an intense and alien environment. The moons of Jupiter also revealed unexpected wonders. Pioneer 10 captured images of Io, a volcanic world spewing sulfur into space, and Europa, an icy moon with a smooth surface that hinted at a hidden ocean beneath its crust. These were not just inert satellites. They were dynamic, geologically active worlds, and their discovery reshaped our understanding of what might be possible elsewhere in the universe. Pioneer 10 didn't stop there. After gathering data from Jupiter. It used the planet's gravity to slingshot itself deeper into space. Pioneer 11 took a similar route, first revisiting Jupiter to collect additional data, then continuing on to Saturn. In 1979, it became the first spacecraft to fly. Past the ringed planet, Saturn was a breathtaking sight. Its rings were more detailed than anything telescopes on Earth had ever shown, composed of countless fragments of ice and rock orbiting in graceful patterns. Pioneer 11 also captured glimpses of Titan, Saturn's largest moon, wrapped in a thick atmosphere, its secrets only partially revealed at the time. These encounters weren't just exciting, they were transformative. The discoveries made by these small probes confirmed that the solar system was far more complex, dynamic, and beautiful than previously imagined. But perhaps even more remarkable than their findings was the distance they traveled. By the 1980s, both Pioneer 10 and 11 had passed the outer planets and were on paths to leave the solar system entirely. In 1983, Pioneer 10 became the first human-made object to pass beyond the orbit of Neptune. Pioneer 11 wasn't far behind. They entered a region where sunlight is barely more than a dim glow, and Earth is just a pale blue dot lost in an ocean of black. Though their power sources were gradually fading and their signals weakening, they continued to send data, faint, precious transmissions from the edge of the solar system. One of the most profound moments came in 1990, when scientists commanded Pioneer 10 to turn its camera back toward Earth. What came through was a tiny, barely visible pixel, but that image captured something deeply moving. Our planet, a single dot floating in the darkness. It was a quiet but powerful reminder of our small place in the vast cosmos. By 2003, Pioneer 10 had sent its final message, its signal too faint to detect. Pioneer 11 had gone silent even earlier, in 1995. But their silence wasn't the end. Both spacecraft continue to drift outward at roughly 27,000 miles per hour, carrying a message with them, a golden plaque bolted to each probe. This plaque, designed by astronomers Carl Sagan and Frank Drake, was a symbolic greeting to any extraterrestrial life that might one day find it. Etched into it are images of a man and a woman, a map showing Earth's position relative to 14 pulsars, a diagram of the solar system and the hydrogen atom, a fundamental constant in the universe. It's a long shot, but the plaque was humanity's way of saying, "We existed. We reached for the stars." As the pioneers moved closer to the edge of the solar system, they began to probe the heliopause, the boundary where the influence of the sun ends and interstellar space begins. Scientists once thought this would be a clean boundary, like crossing a line. Instead, the data revealed turbulence, a chaotic region filled with fluctuating cosmic rays. These high-energy particles, likely originating from distant supernovae, painted a picture of a transition zone that was anything but simple. This revelation helped lay the foundation for what later spacecraft like Voyager would confirm: that interstellar space is not a calm void, but an active, evolving frontier shaped by forces from across the galaxy. The legacy of the Pioneer missions is not only scientific, it's deeply human. With the limited technology of the 1970s, these spacecraft reached farther than anyone had imagined. Their discoveries about Jupiter's moons inspired later missions like Galileo and Juno. Their insights into Saturn paved the way for Cassini. Their golden plaques inspired generations of scientists, artists, and storytellers, and sparked countless imaginations with the idea that we might not be alone. Today, Pioneer 10 and 11 continue to drift silently through the cosmos. They won't reach another star for millions of years, and we may never know if they're found. But that's not what matters. Their journeys are symbols of curiosity, of courage, of our desire to understand. Scientists estimate that Pioneer 10 may pass within a light year of a red giant star called Aldebaran in the Taurus constellation, though that won't happen for nearly 2 million years. Will someone or something discover it? Will they decipher the symbols and wonder about the beings who launched this tiny messenger? We don't have those answers, but the act of asking, of reaching into the unknown, is the essence of what the pioneer missions represent. Their influence echoes through every mission that's followed. When Voyager crossed into interstellar space, it was walking in the pioneers' footsteps. When New Horizons flew past Pluto, it carried their spirit of bold discovery. And as we plan future missions to Mars, Europa, or even beyond our solar system, we're reminded of what the pioneers proved, that the impossible is just a challenge, waiting to be met. Their data, archived by NASA, continues to inform our understanding of the outer solar system and beyond. Every tiny spike in radiation, every faint signal, is a clue that contributes to a larger puzzle. And in a world facing complex problems, climate change, disease, and uncertainty, the story of the pioneers stands as a mirror. It shows us what's possible when we reach beyond fear and doubt. These two spacecraft, launched decades ago, are still out there, carrying humanity's voice into the void. That's the true power of exploration. It isn't just about scientific measurements or striking images. It's about our identity, who we are, and who we aspire to become. So, consider this. Could other civilizations have launched their own pioneers, now drifting through the stars? And might we, one day, build a probe capable of catching up to ours, continuing the journey we began so long ago? The answers may be far away, but the spirit that drove us to ask those questions, that will always be with us,